Let us consider the sentence, I am not Ptyl. Obviously, our old friend Zach would find this sentence perfectly valid. However, for me, it is false. Why is that? Well, it is simply that the term, I, is more meaningful to me than my name. However, if both would have been equally meaningful to me, this sentence would produce a variation of the lie paradox. To explain, if I was to say, I am lying, there would have been no way to determine whether I am more I or more lying. However, when I say, I am not Ptyl, implicitly, it is obvious I am more I than not Ptyl. Still, again, this is obvious only implicitly. There is nothing in the grammar of the language, or the logical structure of the sentence, to suggest it. The same applies to the lie paradox. If I was to say, I am here, with you, in this room. I am Ptyl, it is my name. I am speaking. I am thinking. I am fantasizing. I am lying. I am living, somehow, the paradox would vanish. Indeed, this last example does not produce a paradox, because I used the language in a different manner. Nevertheless, this example shows that neither the meaning of the generalizations we use in our statements, nor the manner by which we put them together within a sentence can create paradoxes by themselves. Only the manner by which we understand a statement may produce a paradox. To clarify, only the sensory we select to determine which thought we should use to understand a sentence can produce a paradox. In other words, paradoxes are products of our beliefs. Arguably, the concepts which compose the lie paradox, namely, the terms, I, am, and lying, are consistent. Furthermore, obviously, placing the terms one after the other, either verbally or in writing, is harmless. Therefore, essentially, the sequence of words, I am lying, is harmless, as well. Indeed, whenever we try to understand this sentence rationally, we fail to do so. However, in itself, this is not a problem, as potentially, there is an infinite amount of word sequences in the English language, which we cannot understand rationally. For example, we cannot understand the sequence, my dog house cat, even though all the words compiling the sentence are in English. Indeed, the grammar of the sentence, my dog house cat, is wrong, while the grammar of the sentence, I am lying, is correct. However, we can understand neither, and therefore, semantically, they are identical. They both represent nothing. However, once we generalize the sentence, I am lying, and give it a name, meaning, the lie paradox, we have a problem, as the term, the lie paradox, does not represent the sequence of words, I am lying, but rather the paradoxical idea this sequence implies semantically. Essentially, by claiming it is a paradox, it implies that conceptually, the sentence is meaningful. Therefore, by generalizing this sequence of words, implicitly, we claim a meaningless sentence is meaningful. To summarize, by subjugating the words compiling the sentence, I am lying, into the concept of a paradox, we imply that the meaning of the sentence both exists and does not exist. Therefore, the generalization, the lie paradox, both exists and does not exist. Therefore, had this generalization existed in the logical field, it would imply the logical field is inconsistent, as it hosts an inconsistent element. While the physical logic is consistent and logical, it cannot suffer from inconsistencies and paradoxes, such as Russell's paradox for example. To explain, Bertrand Russell, a philosopher and mathematician, found a paradox in set theory, which we now know as Russell's set. Russell's set is the set of all sets which do not contain themselves. Obviously, if a set contains itself, it cannot be in Russell's set. However, if it does not contain itself, then it must be in Russell's set. While indeed, this paradox troubled set theory, it does not challenge the physical logic, as according to the physical logic, the meaning of the term set does not exist. Still, there is an additional concrete reason why Russell's set cannot exist in the world. To clarify, regardless if the elements in this set are abstract ideas, or concrete physical elements, we simply could never finish its construction. With each step in its construction, we must still fulfill at least one more task, meaning, to either add or remove the set from itself. Therefore, the generalization, Russell's set, does not represent a set at all. Once we remove the semantic meaning of the term, set, Russell's set transforms into a process that never ends. Therefore, Russell's set could never appear in the world, because to transform from an idea into a real set, meaning a collection of items, this process must end. Therefore, while indeed, Russell's set exposed inherent flaws of set theory, again, it does not challenge the physical logic. On the one hand, sets do not exist in the logical field. On the other hand, infinite processes do exist in the logical field, as arguably, the persistent existence of space embodies such a process. To conclude, again, while the meaning of generalizations can lead to paradoxes, we cannot map such meanings onto elements in the world, and therefore, whenever we generalize, we distance ourselves from the limitations and circumstances of actual occurrences.